Hey guys, thanks for joining. Today I'm going to be introducing Pandas in Python. So Pandas is hands down the most used library for Python for data science. It allows you to manipulate data with ease. And then if you use it on Jupyter Notebooks or Google Colabs, it allows you to see the data sort of like how you would see it in Excel in table format. And then it's built on NumPy, so you have that basically that ease in terms of slicing the data or doing mathematical operations on the data, just like with NumPy. If you don't know NumPy, I did a few videos on that. I suggest you watch a few of those to get acclimated with the concepts. Today I'm going to keep it simple. I'm just going to introduce to you Pandas and Pandas Dataframes and a few things that you can do with Panda Dataframes. All right, and you can follow along with me by downloading this Python notebook in the link below. You can open it up in either Jupyter Notebooks or Google Colabs. I have it open right now in Google Colabs. And you'll even find a supplemental Python notebook with exercises to practice, as well as solutions for reference in the link below also. All right, so let's get started. The first thing I'll do is I will import pandas. And the way to do that, very simple, is just import pandas. If I want to actually check the version, I can check it by just doing a double underscore version and then double underscore. And if I execute on that code block, and all I did was just press shift return and it'll run the code. The pandas version is 1.03. The other way of running this code block is just pressing this play button here. They're both the same thing. So either press the play button or press shift return. So generally we want to actually import pandas and give it an alias. So I'm going to give it a PD alias, which is generally how you'll see it. So anytime I refer to a function or to a method in the pandas library, I'm going to prefix it with PD. So that'll be obvious just in the next slide or next code block below. So creating a series object, a pandas series object, is basically creating a one-dimensional array, which is basically the same thing as creating a one-dimensional NumPy array. They're all both analogous. So in order to do that, what I'm going to do is call the PD library and then use this function called series, which is going to allow me to create a one-dimensional array. So within these parentheses, I'm just going to add in my data, and my data is going to be a list of values. And that list of values needs to be enclosed in brackets. So I'm going to have that. I'm just going to put in a few decimals for values. Maybe just 4 values to start. And if I execute that, I get this, right? So actually what I want to do is I want to save this, pandas series in a variable called data, because I'm going to be playing around with it. And so what we have here are the 4 values that I put into the list or into the array. It's a data type float 64, so it means it's a 64-bit float. A float is a data type with a decimal, and we have decimals here. And then on the left, you'll actually notice an index. Python will always start at 0, so the first index or the first value will always be referenced as a 0, and then it'll just iterate by 1 every single time. But we have 4 values, and we have an index here, and the index basically ends at 3. All right, so that's basically what a pandas series object is. So there's a few characteristics of a pandas series object. First one is using attributes. So an attribute to just get the values of our pandas series is to use the values attributes. This is the same as the NumPy values attribute. So this will output just the values. And so obviously we have 4 values that create the pandas series, and we have 4 values in this array. If I just wanted to understand the index, so this right here, this left-hand side, I can use the index value or index attribute. And what it'll say is that our array range index starts at 0, which it does up here, and it'll stop at 4 and step by 1, right? And so stopping by 4, it looks like it actually stops at 3. So stopping at 4 means it's just stopping at the 4th value, which is actually an index 3. And step by 1 means that it's incrementally increasing by 1. So the index will allow you to grab certain values in your Pandas data frame or Pandas series. So for example, if I wanted to grab this 0.5 value here, like how would I do that? One way to actually do that is to just reference this index right here, just like you would with a NumPy's array. So I would just type in data, and then I would have a bracket to indicate that I'm going to put an index value inside the bracket. So I'm going to put a 1, and that should give me 0.5, right? So that makes sense. An index of 1 will give me 0.5, just like how this series is defined. So what if we wanted several values in this Pandas series? We could use slicing notation, right? And so slicing notation, again, it comes from the concept in NumPy. So if you're not familiar with slicing, I suggest you watch some of the NumPy videos that I have on my playlist, and it'll go through that concept. But if I wanted to grab just, say like these middle two values here, 0.5 and set 0.75, I could just use the slicing notation of 1:3, and that should give me 0.5 and 0.75. So let me break that down for you in case you don't understand how 1 and 3 would give me these two values here. So one way of thinking about it is, Python starts at 0. So 1 actually refers to the second value in that array. And that's the reason why I have a 1 here. So that's the start. And the stop is 3. So we know that the third value, or basically the third index, is actually 0, 1, 2, 3. And it's exclusive. It's not going to actually include the 1. It's going to stop at this line right here and only give you or include this line. So if I start at 1, and then that being inclusive, and I stop at 3, and 3 being exclusive, it should actually only give me this. So 1 and 2, which it does. So in order to create a simple data frame, what we're going to do here is follow this syntax, PD data frame. And this data frame is a function or a method that is written in Pandas. And what you're going to do is you're basically going to have these curly brackets at the start and at the end, and then you're going to basically have a column name, colon, and then its value, and then a column name, colon, and then its values. And for however many column names you have, you also have values, right? So in order to just illustrate this example, I'm going to have a Pandas data frame called df, and I'm going to then use and call the Pandas library and then the method data frame here. And just like to make things easier in terms of looking at the code and understanding and digesting it, I'm going to just format it the way I like to format code, which is more or less lining up these brackets. And then I know I'm going to have these squiggly brackets or curly brackets on the end. Oops. It's not going very well. Whoops. All right. So I got the syntax. I know that I have this going for me, and now I can actually start entering the column names and the values associated with each column name. So the first column name I'm going to have is one called name, right? And then I'm going to actually put multiple values in here. And so multiple values should always be captured in a list, and a list should always be captured or start with brackets, right? So if I want to have 3 names, I'm going to start off with this bracket, and then I'm going to type in the 3 names. So Bob would be 1, Jen would be the second name, and Tim would be the third name. I'm going to then add a comma and go to the second line. And in that second line, I'm going to have the second column that I want in this data frame. It's going to be a column to capture their age. And so then I'm going to have 3 ages, 3 values. So it's going to be 20, 30, and then 40. And you see that it changed, the text color changed to green. And that makes sense because it's a number, it's an integer. So integers are captured as green in Google Colabs. Text strings, that's captured in red in Google Colab. So that's why Bob, Jen, Tim, name, and age are captured in red. All right, so now I'm going to add the third column. That will be a pet column. And I'm going to enter in what type of pet they have. So again, I'm going to put 3 pets in an array or in a list, and that list is going to start with brackets. So maybe Bob will have a cat, maybe Jen will have a dog, and Tim will have a bird. Whoops. So now I know I did something wrong because dog and bird are in black, and so I didn't enclose cat in the ending quote, single quote. So I'm going to add that, and now everything is fixed. All right. So now I have that. I'm going to just tidy things up a little bit, and my data frame kind of looks like this. I'm going to have a df at the bottom so that I output what the data frame looks like. And so I'm going to execute this code block, and I get this data frame. And it looks pretty nice. I have the name column, the age, and the pet. And then I also have this index here, 0, 1, 2. And I'm going to always have that for every single Pandas data frame. All right. And that's going to be important for the next concept that I'm going to introduce, which is indexers, loc, and iloc. So loc and iloc are important because they will allow you to index and slice your Pandas data frame. So they're essentially like functions and methods that allow you to slice and index your Pandas data frame by explicitly or implicitly calling certain index values. So I'm going to illustrate this example. I am going to actually create a new Pandas data frame. I'm going to create a one-dimensional Pandas series. So really quickly, I'm going to create a series here. Maybe I'll just make it easy. I'll just do A, B, C. And then I'm going to give it an explicit index, like an index that I want to give it. So rather than starting at 0, 1, 2, I'm going to give it 1, 3, and 5 as the values for the index. And then I am going to output my data. Whoops, that's not good. Oh, okay. There you go. And so what I have obviously is an index of 1, 3, 5, which I asked for here, and the values ABC, which I put in a list here, and I have ABC and data type object, which is exactly right. There are a bunch of strings, right? So to now call specific values, what I can do is just like above. Well, if I wanted to call A, I could just type in data 1, and it's gonna give me A, right? It's explicit in this case. So maybe just for the Python notebook that you can download, you'll probably see this. I'm gonna write explicit index when indexing. All right, but there's also implicit. So implicit is basically the default behavior when slicing. So I'll write that down also. Implicit index when slicing. So what I mean by that is if I want multiple values if I'm trying to get multiple values, I will be using the slicing notation, right? So I'm going to be writing something like this. So that slicing notation, that's basically going to be giving me two values. It's going to be an implicit index, which means that 1 and 3, let's actually just execute so we know what we're getting. We're getting index 3 and 5, we're getting B and C, right? Which is kind of weird, but it's because it's an implicit index, which means that this is actually the first position, which in Python, it's actually the 0 position. It's actually index of 0. And then when we start at index of 1, we're starting here. And then when we stop at 3, that's actually stopping on basically a 4th position that doesn't exist. But this is essentially the second index here, right? So you have index 1 and you have index 2, and then this top one is index 0. So an implicit index basically means that it's actually going off of positioning rather than the value of the index itself. So I could write here, just for your note taking, explicit equals the index value, and implicit index refers to the position of the index in Python. Positions start at 0. All right, so that makes sense to me, why we would get 3 and 5. So this is obviously super confusing, and nobody likes to basically have to memorize all of these things and then still probably make a mistake. So what we have is actually the concepts of loc and iloc. So loc you can refer to as an explicit index, and iloc, the I in loc stands for implicit Python index. So let me just demonstrate what that actually means and how to use it. So if I want to demonstrate loc, which is explicit, we could do this, which will give me A, which is exactly like basically what I showed before above. It's the same thing as this. And if I wanted to use explicit indexing for slicing, which is this thing right here, what I can do instead is just do data.loc, which is explicit indexing, and if I do a 1-3, it's actually going to finally give me index 1 and index 3, which is AB, and that's the reason why I have AB here, right? So that's a lot easier to just understand and read, knowing that loc is an explicit index function or method. And then iloc is implicit, so the I is implicit, right? So if I kind of just do the same thing, data.iloc, and I'm giving it a 1, I'm going to get the value B. And so if I'm going to actually, to make it a little easier, just export out what data is. So if I have this 1 here, I'm getting a B, because if I'm looking at what an implicit index is, it's positioning, right? So the first position, or really in Python, it's 1 refers to the second position. My second position is going to be B. Okay, right? Just for simplicity, 0 should be the first position, and I get an A. And that illustrates that example there. In Python, the 0 number in an index is the first position. So I say that many times because I'm really just trying to drill that in your head, so that you can remember. Just to complete this concept, let's do iloc for slicing. And we get basically what we think we're going to get. Just based off of positioning, 1 is going to be the second position, which is going to be B. And then when we end at 3, we're ending basically at the end of the Pandas series, which is the third row, which will give us a C. So this is just by position, right? This is implicit. And so you can use iloc to refer to positioning of an index, and you can use loc to refer to the actual explicit index values. So depending on how you understand your data, depending on the data itself and the index of the data, you might use loc or you might use iloc. It really just depends. All right, so we are going to next use our data frame that we created above, the ones with Bob, Jen, Tim, and their ages and the pets that they have. And I'm gonna talk about this concept again and get slightly more complex with some of the examples we're gonna use. Okay, so we're gonna have this data frame here, and just to illustrate some of these concepts, I'm gonna actually sort the values, sort the rows a bit. So I'm gonna what I'll do is sort on pet, the column pet. In place, we'll just do it in memory so that I don't need to save it again to another data frame. What I'm gonna get out of that is, let's see, let me actually output it. I should get now Tim at the top, Jen at the bottom, Bob in the middle, and the index now is shuffled around, right? Because I sorted based off of pet, and bird starts with a B, cat C, D dog. So that makes sense. It's in alphabetical order. And we can understand basically the index values and how it got reshuffled or shuffled just based off of this shuffling of numbers, of index numbers here. All right, so to illustrate the concept now of loc and iloc, let's look at how we would obtain Bob here, right? And so there are several ways to obtain Bob. And so if I wanted to use the loc method, I would do df loc, and I'm just gonna give it the 0 value here because I know the explicit index value. So I should get Bob here, which I do. And so I'm getting the entire row, Bob 20, and he owns a cat. Okay, and now to complete this example and to illustrate iloc, if we did iloc, which is basically an implicit indexing, which is based off of position, if I put 0, I'm not actually referring to this row right here. I'm actually referring to the first position or the first row, which is actually a value of 2. But because of iloc, it's on the position index. I'm going to get exactly that. I'm going to get the first row, which is Tim. He's 40 years old and he owns a bird. So that's the difference. That's another illustration of loc and iloc. And now we can get slightly more advanced with it and talk about multi-indexing using iloc and loc. And so I'm going to use iloc as an example first and try to select all the rows of a column. And so what I mean by that is in this example, I'm going to just try to select this whole column here. And how do I do that? So just like in a NumPy array, what I can do is, if I want to use iloc, I can use the syntax colon, which gives me basically all of the rows. So colon just means basically give me everything. And because this is the first position or the first parameter, it means rows, right? It refers to rows. And then the second parameter, it actually refers to columns. And so if I want to get the pet column, I know that if I'm using iloc, we're talking about positions. This is position 1, age is position 2, and pet is position 3. But Python starts at 0, right? So name is actually 0, age is 1, pet is 2. So I'm going to put a 2 there. And I should get bird, cat, dog. And that's exactly what I get. If I want to select the last row, there are multiple ways to do this. My favorite way is to use reverse indexing. And if I wanted to get the last row, which is grabbing Jen, 30, dog, and I know that the row is the first parameter, and I'm going to use reverse indexing. I'm going to type in a -1. And then because I want all the values in that row, it means that I want all the columns, and I'm just going to put a colon as the second parameter. And I should get Jen, 30 dog. All right, and so that's how I use iloc and how I use implicit indexing or positioning of an index to capture and export the values that I want from a pandas data frame. Okay, so we are now going to expand on the concept of data selection, slicing, and referring to indexes to basically get the data that we want out of the data frame. So we're going to create a data frame as a dictionary. So what I mean by that is a dictionary has a key and a value. And so what we are going to do is create two pandas series right here, which I have as area and I have as pop for population. The key there, the keys I should say, are the states like California and Texas, and the values are these numbers here. So this is the area, and then for the pop variable, the pop data frame, that's population. And then once I have these pandas series, I'm actually gonna put it into a pandas data frame to create a multi-dimensional pandas data frame. So all of this code is already written out for you in the Python notebook that I have in the description. So it's easy to just kind of download it and just execute this line of code. And this is what you get. You get, instead of an index that has values of 0, 1, 2, 3, you get an index that has these values, these states. And then you have columns like area and population or pop. Right? Okay, so if we wanted, for example, to get just the areas for every state here, so basically the areas for all of the rows, or this entire column is another way of asking the question. What I can do is I can just explicitly ask for that area column to be displayed. So I have data as my data frame, and then I'm going to type in the column name, which is area. And remember to put single or double quotes around it because it's a string. So Python needs to know that it's not a variable. So variables don't have quotes around it. So it needs to know it's not a variable and that it's a string. And so you have to put these quotes around it, and it needs to turn red in Google Colabs. And once you have that, you will then get all of the states which is the index, and then the area I think is in square footage. So you have basically all the values here. So another way of doing it is just writing out what the attribute is. This is also very easy. So data here is the data frame. It's also called the object, and an attribute is connected to the object. So this attribute area is connected to data, and it's going to give me basically the same thing, right? So, there's two ways to do this. Most people in general will always use this because sometimes there are functions or methods that are the same as basically your attribute name, and it might conflict and you might get an error and you might not know why. So in order to just not get these edge cases, it's just better to stick to one type of way of like writing code or syntax. And this is kind of the way most people write it that I've seen in code, when in the code that they write. And so just do it this way just to make it simple. So we can also create new columns, and we can also do some math on these values or these numbers that we have saved in the data frame. So just like NumPy, it's exactly the same thing. If I wanted to get maybe a normalized number like density, which is population divided by area, it's really easy for me to do that. So I'm just going to call the population column, and I'm just going to execute that so it displays. And then I'm just going to divide it by the area column, which is this. And when I do the division, I get the density right there, right? But it's not saved anywhere. And sometimes I want to save it back as a new column in the original data frame. So an easy way to do that in Pandas is to just create it on the fly. So we're going to create a column called density. and we're going to make it equal to population divided by area. And so if I execute this line of code, it's going to be successful and not actually display anything. But if I display the original data frame, I now see density as its own new column. All right, so now let's just do a few things with this data frame that we have data. So if I have something like this and I wanted to grab its values, all of its values on a two-dimensional array, I can just do it just like how I would do it with a one-dimensional array, which is just use the attribute values. If I could also easily transpose this. So what I mean by that is the index is basically the states here. Sometimes it's actually better to have this instead of rows be columns, and then the area, population, and density be the rows. So basically just like move it 90 degrees or transpose it. An easy way to do that is to just do type in a capital T there, and you have the whole database transposed. That's in some cases a better way to actually visualize the data. All right, so now let's just talk about iloc and loc and grabbing certain values from these two-dimensional data frames. So I'm going to just output the data again and say for whatever reason I want to grab the first row of values. I want to just grab the area of California, population and density of California. So in order to do that, and if I just want the values, what I can do is just do values. I know it's gonna, if I run this, it's gonna give me all of the values. If I just want California, I know it's actually the first row. So I'm just going to do a 0 for the positioning, and that's what I get. So now let's talk about using iloc and loc to grab data that we want, a subset of data that we want from a bigger data frame. All right, so just to illustrate an example, if I have this data frame here, and say that I just wanted some of the data, not all of it. Maybe I just wanted the first 2 columns and the first 3 rows here. So California area and population, Texas and New York area and population, and I didn't want to display anything else. How would I actually achieve that? So I could use iloc, and then the hard part is actually figuring out what numbers to actually put in, right? I know that the first parameter in iloc is going to refer to the rows. So it's going to refer to, California, Texas, and New York. And essentially what I'm going to do is I'm going to type in :3. I think it's going to give me the first 3 rows. And the way I'm thinking about it is I'm going to start at 0, right? A position of 0 at the index. So implicitly, I'm not going to write anything here. And then I'm going to then stop at New York, which is index of 0, 1, and 2. And then I know Florida has an index of 3. So I'm actually going to type in a 3 because it's exclusive. The stop is always exclusive. And so in order to include New York, I need to stop at Florida so that it's going to give me New York. All right. And then for the column, same concept there. I'm going to have a colon because I want to start at area. And implicitly, I'm just basically saying start at the very beginning and then end at what number would that be? So if this is the 0 position, this is the 1 position, and this is the second position or second index, I would actually want to stop at the second index so that it includes this population column. So if I put a 2 there, that's exactly what I get, right? I get basically 3 rows and then 2 columns here. So that was kind of difficult because these numbers are such an abstract concept. So another way of kind of doing that is say that I wanted, for example, all of these columns and I wanted just the area and population. Well, I can use iloc and I can use these numbers and get it that way. Or maybe a simpler way is to use loc, because then I can just specify the values that I want without really thinking it or overthinking it. And so what I'll do now is, if I want basically all of the rows, I can do that, just a colon that will give me everything. And then if I just want the first two columns, I can then just type in start at the beginning, so there's an implicit colon here, or implicit value and then a colon, and then just stop at pop. So that can just give me population. And that's what I get, right? I get basically all of the rows, and I get starting at the first column and ending at population, I'm getting area and population. So that could be an easier way to think about things. But for the most part, a lot of practice is how you're gonna get it. You can just use iloc and just think about it that way, or you can just use loc and just think about it that way. But for the most part, it's just a lot of repetition and a lot of just practice. So another concept I want to introduce is the masking concept that we can use for Pandas Dataframes. So the masking concept comes from NumPy arrays, and it's essentially using mathematical operators to create logic, and if that logic is actually met, then that value will be true, and it would be potentially shown in the Pandas data frame. So let me just illustrate what that means. So I'm going to call the data frame data again that we've been using. I am interested in states where the density is greater than 100. So maybe it might be worthwhile for me to write this down so you can follow along. Interested in states where the density is greater than 100. I want to also output just the population column and the density columns. All right. So that is actually just going to be these four numbers here with like the states attached to it. And so how can we do that? Well, we can do that by introducing the masking concept and putting in some logic operators. And so I'm going to introduce the loc. And then what I'm going to do is put in this density logic here. So in order to do that, I'll put density or data.density. I want it greater than 100. And so that's just saying that, the data frame data and the column density give me the values or the states where that's greater than 100 for density. And then what I want to do is just output the pop column as well as the density column. And if I close all of that up, I get exactly what I'm hoping to get. I'm getting the densities that are greater than, the states where the densities are greater than 100, which is basically this logic line here, this masking operator here. And then it's giving me just the population and density columns that I'm showing here. So that's how you can kind of use masking operations to basically output, the data that you're interested in. Using these mathematical operators and logic. Another concept I wanted to introduce is, just overriding values, for example, and saving it back into a data frame. So I'm just going to give you an example here. If I wanted to maybe just round this off to 90.0000 rather than 90.4139, how can I just override that value? Well, it's the same way of doing it like you did in NumPys, where you would specify the position. So specify where this position is in the data frame and then make it equal to a value. So in this case, you can use loc or you can use iloc. I'll just use iloc. The first parameter is going to refer to the row, and it's going to be the first row. And we know in Python, the first row or the first position of anything is really a value of 0. The second parameter refers to a column. We know that it's the third column, but again, the third column is really a value of 2, right? Because this index, it's 0, and then it's 1, and then it's 2. Right, so let's actually just see what we get here. We get 90.41. That's exactly, let me just show it to you again if you have a bad memory like I do. Right, so it's this. So it's right. It's exactly the position where we want to change the value. And I'm just gonna make it equal to 90. And then if I call data back up, I get 90 right here. So let us finish this off, and I'm gonna just introduce 3 not new concepts, but just indexing conventions, just like other ways of slicing and calling different values from your data frame. So one way of indexing, we can refer to columns. Even when we're slicing, we can refer to the column names or the index names. So for example, if I have the data frame that we've been using all along, and if I just wanted to grab all the values in Florida and in Illinois, like how would I do that? There are multiple ways of doing that, right? We can use loc, we can use iloc, we can use masking, we can use all of these different techniques. One easy technique is to just call it by the index names. And in this case, it's Florida, start at Florida, end at Illinois, and I get just these 2 rows. Super simple, right? What if I wanted to use numbers instead? So let's just start again with looking at the complete data frame. What if we just wanted to grab the second row and the third row? How would I do that? We can call it by its name just like above here, but if we wanted to use numbers instead of strings, we can call it, we can refer to Texas, which is the second row, with its index position, which is 1, right? And so just to, again, drill this concept in your head, the first row is always the 0 position, and then so that means that the second row will be a value of 1 in an index, like an index of 1, and then New York here will be it's actually the third row, but it's actually a value of 2, right? Because it's 0 here, 1, 2, and then Florida would be 3. It would have an index value of 3. But because in Python, the stop parameter is always exclusive, we're going to stop at Florida so that we can include New York. So we have, in order to stop by Florida, we call its value, which is an index of 3 here. All right, so maybe just let me write this down in case like you're more of a visual learner instead of an auditory learner. So 1 refers to the second row and is inclusive in the start parameter. And then 3 refers to the fourth row and is exclusive in the stop parameter, right? So start parameter would be the first parameter here, and the stop parameter would be the second parameter in the indexing brackets. All right. And then the last thing I wanted to introduce again is the concept of masking. So again, if I started with our original data frame and I wanted just all of the states and all of the information where the density is greater than 100, how would I do that? Well, I would just in this bracket, I would just call the density function. So one way to do that is just to call, sorry, not the function, the density column. And I would say I want the densities that are greater than 100 to be displayed or to be considered in this output. And then that's what I get, right? And then another way of writing it also, if you don't want to write it this way, is to write it this way. And it gives you the same thing. All right. So that is a very quick overview of Python Pandas that allows you to create Pandas data frames and basically manipulate it in a few different ways and also extract different values or subsets of values within that data frame.